Hi everyone, my name is Jackie and I'm an educator at the Milwaukee Public Museum. This month's Community of Curiosity theme is the rich indigenous cultures of North America. We're exploring birchbark canoes, which are a really amazing and complex technology. A canoe is an artifact, something made or shaped by people. Studying artifacts helps us learn more about the people who made them. Canoes demonstrate the various skills and knowledge of Great Lakes Native peoples, like knowing the right time of year to collect the birch bark best suited to this purpose, the best types of wood and plant fibers to use for the frame and lacing, and how to bend, shape, and cut the wood. The activity accompanying this video includes a link to an excellent video showing the process of making a canoe from beginning to end, and we really encourage you to watch it. Creating a watercraft also requires an expert understanding of buoyancy. We can explore this further with some simple materials you can find around the house. But before we get started, let's talk through the science of buoyancy. If we put something in the water, like a boat, there are two forces at work. Gravity pulls the object down, and buoyancy pushes it up. Buoyancy is the force the water applies to the object. The object moves water out of the way. Think about how your body moves water out of the way and makes the water level rise when you get in the bathtub. The more water the object moves, the stronger the buoyancy will be. If the object weighs the same as the amount of water it moves, it will float. The way the object is shaped can also change how much water it moves and whether or not it will float. This might sound complicated, but you can test this with simple materials from around the house. You'll need a dish or pan that can hold a few inches of water, aluminum foil, a stack of quarters, and a handful of objects that are safe to get wet. So here at home, I have assembled my pan of water with a couple inches, a leaf, a stick, a hard plastic ball, a pair of sunglasses, #GoPackGo, and this Bucky Ducky mashup. This first activity is really meant for early learners, so take a few moments to make some observations about the household objects you've assembled. Look at how they're the same or they're different. Think about questions like which ones are heavier, lighter, bigger, or smaller. This will help your child connect descriptive words with what they're seeing and observing. Then use your observations to make some guesses. Which objects will float? Which objects will sink, and why? Then test your guess by placing the objects in the water and observing if they sink or float. So here I have this hard, pretty solid black rubber ball and my Bucky Ducky. So my guess would be that based on the weight and the way it's shaped, the ball will sink and Bucky Ducky will float. So let's take a look. Bucky Ducky's riding pretty low, but it does float. And black rubber ball, not surprisingly, sinks. So we have some objects from outside, a stick and a leaf. Looks like leaf floats. So does the stick. And last object, Packer's sunglasses. I don't know, this one's kind of a toss-up. It's not that heavy. We'll see. Oh, straight to the bottom. Oh well. If you want to explore buoyancy further, take your aluminum foil and shape it into a boat in whatever design you think will best help it float. Test your boat's effectiveness by loading it up with quarters. How many quarters can it hold before it sinks? If you change the design, does it make the boat better equipped to hold more quarters? Experiment with different designs. So let's remove the objects we used previously. I have made 2 boats ahead of time, and I am not an engineer, so if you're not an engineer either, don't feel bad. So I made one boat a little bit wider with a bigger, flatter bottom, and this one with a much smaller bottom but with higher sides. And I have a big stack of quarters here. So if we test this out, loading the boats up with quarters, we can see what happens. We can also experiment with what happens if we place quarters in one specific spot in the boat, or if we spread it out across the bottom. Lots and lots of different ways to explore buoyancy, shape, and weight with this. And it looks like both of my boats are going to keep floating for the time being, although that might change if I continue to load it up with quarters. If you're interested in learning more about birchbark canoes and native technology, visit us online to keep learning. Also, be sure to check our website for other great activities in our monthly Community of Curiosity space. Stay safe and healthy, and we hope to see you soon.